So today we're going to be doing convolution. So basically what convolution is you're taking two functions and you're basically comparing them in a way where you convolute one of them on the other. So what that means is you reverse it and you basically iterate it over a period of time, in the sense of you're multiplying each data point with the other function, and then you're multiplying that, and then you get this average, if you will. And apparently that's also what is behind the normal distribution when you're working with probability. It's actually related to convolution. So in this example, we have some assigned values here. So x of t equals u of t, h of t equals e to the power of minus 2t ut. And then this is what we want to find, and we denote convolution with a star here. So basically with convolution we want to find the third function, which is yt, which is the convolution of xt on ht. And this is the convolution integral here. So this is just by definition, and the limits are usually at minus infinity to infinity, so it's an integral sign here, and we're using tau as a dummy variable to work out the causality limits. So here, x of tau times h t minus tau, we can plug these variables inside here, so we get t equals the integral between minus infinity to infinity u tau, which if you see here, it's this, and then times e to the power of minus t times t minus tau. Because we're not working with t, we're working with t minus tau, so that's why we get this here, because of this here. And yeah, and this is just carrying on here. We're replacing t with t minus tau because of h. So, and then we're just doing, integrating to the respect of tau. So the way that we find these causality limits is we basically want to find out where tau is not equal to 0. So here it's just tau, so we can just say tau is greater than or equal to 0. If tau is greater than or equal to 0, it will not be 0. And here, because t minus tau, we can say if tau is lesser than or equal to t, then it won't be 0. So putting that together, it will be t is greater than or equal to 0 and t is lesser than or equal to t. Those are the limits. So you can see that here, from 0 to t, and this is where we have this here. These two variables here actually go to 1, apparently, when you change the limits. So you're only left with this here. This is the actual meat and potatoes of our function. So what we can do here is we can simplify this function by understanding the power rules. Because this is bracketed, we can factorize, well, I guess unfactorize this by saying minus t times t, so that's minus 2 times t, so that's minus 2t, and then here is minus 2 times minus tau, so that's 2 tau. So here it's so here it's e to the power of minus 2 t times e to the power of 2 times tau to the respective tau. And we're integrating over 0 to t. Because this is respect to tau, we can actually treat this as a constant, because this is just t, and we're we're not actually integrating with respect to t. So we can treat this as a constant, so we can take it out of the integral. So the only thing we're left with is this here. Sorry, I made a mistake here actually. I should write 0 here. And when you integrate e to the power of minus t, well, e to the power of minus 2t, e to the power of 2 times tau, you get 1 over 2 times e to the power of 2 times tau. So here you're just taking the coefficient variable in the exponent, and you're just creating a fraction. So if this was 3 tau, it would be 1 over 3, and so on. Yes, so because we already have this, it's kind of weird how this works. I guess it's gonna kind of almost be like this in a way, where it's gonna be 1 over half, and it's gonna be like we want to, like, we're gonna integrate t and then 0. So here this is e2t, and then minus e to the power of 0 is 1, right? So this is what we're going to end up with here. And as you can see, this is actually what we do end up with. And then times that. And what's so interesting is if we want to simplify this even further, we can by multiplying this here into this fraction, parentheses, I guess, brackets. So when we do that, we get e to the power of 2 times t minus 2 times t, and that will just equate to 0, and then minus e to the power of minus 2 times t. This will go to 1, and this will go to minus e. Well, it's already still the same. But yeah, that's the final answer for this question. So now we're going to carry on. So let's continue with problem 1 here. So for problem 1, we have xt equals ut. Ht equals ut minus 2. And then it says find yt equals xt to the convolution of ht. And also with convolutions, it doesn't matter the order here. Like it could be ht, convolution, xt, it doesn't matter because they're going in opposite directions. You can look at it either or. You can look at it either way, it's still going to be the same. So I'll just write this. Star ht. And then we can write the convolution integral here. Convolution integral. So minus infinity to infinity. And then we have u tau times h t minus tau d tau, I believe. Is that correct? Oh, sorry, it's x tau. Whoops, sorry about that. Always make mistakes sometimes. Okay. So, now we can plug this all in here. So, it's infinity to infinity. So we have u tau. Sorry about that. U tau times h. Well, what is h? It's u t minus 2. Okay, so this is going to be interesting. So this is going to be u t minus 2, and this is in brackets here. So we'll just do the brackets out here actually. And then minus tau, like so. Yeah. And then d tau. So now we have to figure out the causality limits here. Sorry, causality limits. So what we're going to do is, so u tau, we're going to start with u tau, and that's easy. So u tau does not equal 0 when tau is greater than or equal to 0. And, okay, this is a bit of a big one here. I don't want to write this out again, so I'll just copy this, send it over, I guess. So ut minus 2 brackets minus tau does not equal 0 when, let me think. I guess like t minus 2. Like usually it would be when t is lesser than or equal to t. But now it's t minus 2. So maybe it should be tau is lesser than or equal to minus 2. Tau is lesser than or equal to, I'm not quite sure. I don't know if it's minus or plus 2. That's my question, I guess. I'm not too sure. T minus 2. I mean, if this is the same as t, it's still going to be minus 2. So it'd have to be 2. Wait, let me just fix this real quick. So usually would be t. If it's t minus tau, and tau is t, then it would be 0. So I guess it needs to be less than t. But here it's minus t minus 2. I mean, wouldn't it just be t minus 2? I think. I'm not too sure. Possibly. I'll just try this out actually. I seriously am puzzled by this one actually. 0 t minus 2. And then these would go away. Sort of, right? I guess you'd only be left with 1 d tau, like that. And then this should be t minus 2. I don't know. I'm not too sure about this one. Just ask ChatGPT. So tau is lesser than or equal to t minus 2. I actually did that correctly. Nice. T minus 2. Yeah, so that is actually correct. That's interesting. And then the last thing you need to do is just put this in. yt equals like that. T minus 2 times y t minus 2. Okay, so let's do problem 2. So here you have x t equals u t minus 1. ht equals u t minus 3. And then I guess yt would just also be this here. ht. And then the causality integral again. Integral minus infinity to infinity x tau h t minus tau respect to tau, and then I'll just place these in, I guess. And beyond. T minus 1, and then this should be u t minus 3 minus tau d tau. And then we check for causality limits again. I spelled causality wrong. Oh well. Yeah, I mean, I don't see why I couldn't just do this. Okay, so u t minus 1 does not equal to 0. Oh, you know what? I forgot to do something here. Does that actually matter? I don't know. Does that actually matter? I don't know whether to make this tau minus 1. Oh well. Let's just do t minus 1. Does not equal 0 when You know what, I actually think it might be. Because there needs to be a tau in here, right? So tau minus 1. So does not equal 0 when tau is it will usually be tau is greater than or equal to 0. But here it's minus 1. So tau minus 1. So you need to go up 1, right? So greater than or equal to 1. And then this one here. Does not equal 0. When tau is lesser than or equal to t minus 3, right? And then you just mess with these again, change the limits for this. So it'll be 1 and then t minus 3. And then it'll just be 1 d tau. And then this would be t minus 3, I believe. And then it'll be y t equals minus 3 u t minus 3. I think that is correct. So I'll just ask ChatGPT. T minus 3 minus 1. Oh yeah, because it's, oh, silly me. It's 1 here, of course. So I'll just change this real quick. Yeah, of course. So this would be t minus 4. Yeah, so it'll actually be t minus 4 u t minus 4, of course. Yeah, I'm just gonna stop there, but yeah, that's just convolution.